Hi, my name is Zeus Nanikon, and today I am going to talk to you about a broad question that I came up with. Why do Saturn and possibly other gas giants have extremely hot atmospheres? Well, let's start off why I chose this question. I chose this question because I was genuinely curious on why Jupiter, for example, a gas giant, it's much more farther away from the sun compared to Mars. Mars is much more closer to the sun. So why does this planet have an extremely hot atmosphere? Shouldn't Mars be hotter? If you think about it logically, that makes sense. So, yes. The reasons why there are extremely hot atmospheres in these gas giants is because one, the auroras from the sun causes the high temperatures in Saturn to go up, and Jupiter as well, possibly other gas giants. And two, the fusion of the composition in these gas giants give off heat, right? If you don't know what a gas giant is simply a planet made out of gas, entirely gas. We can see there are four gas giants in our solar system, which include Neptune, Uranus, Saturn, and Jupiter. So yes, those are all the gas giants. And in Jupiter and Saturn, the main compositions, well, in all of the gas giants, the main compositions include methane, ammonium, hydrogen, and helium. So let's see, when hydrogen and helium fuse together, they give off heat, right? And the production of heat causes the temperatures to go up, and it contributes to the extremely hot atmosphere in the planets, right? We can also see this with stars, right? When hydrogen and helium fuse in stars, they emit heat. So now let's talk about auroras. I'm going to try to explain this in the most efficient way possible by using Earth as a reference, since we know it and we understand it way better. So, here it is. This is a diagram of how auroras are formed. So auroras are caused by the sun that sends heat and light. And when the energy travels down a magnetic field lines through the north and south poles of the Earth's atmosphere, the sun's energy particles interact with our atmosphere and displays one of the most beautiful lights in the sky. Okay. And I will show you a picture of the Aurora Borealis and Australis, also known as the Northern and Southern Lights. I swear, when I say this is one of the most beautiful creations ever created by Mother Nature herself, it truly is. Just look at those dazzling lights. You can see like the oxygen gives off the green and red lights, while nitrogen gives off the blue and purple light. So yes. You might ask, how is this related to the extremely hot temperatures in these gas giants? Well, I'm going to talk about it. So we know that auroras are formed when the energy from the sun goes through the planet's magnetosphere, right? A magnetosphere is simply something that deflects most of the particles that's coming from the sun, but it also traps some of the particles towards the some of the particles in towards the magnetic poles, and it causes the auroras. So what was I saying? Right. So you can think of magnetospheres. One thing magnetospheres have in common with greenhouse gases is that they both share something in common, which is that they trap heat, right? And if you don't know what a greenhouse gas is, basically is a gaseous compound that traps heat from the sun, traps light from the sun, energy from the sun, right? And it causes the global temperatures to go up, and it contributes to global warming, right? And we can see when the temperatures go up, it melts our ice and causes climate change as well. And we can see that's happening in the North and South poles. And yeah, the polar bears, I feel so bad for them, but what can we do? Yes. But in Saturn, these particles from the sun that goes through a magnetosphere and causes the auroras, the auroras are also accompanied with electric currents that generate heat. This is also known as Joule heating. So yes. I don't know if I showed you this before, but This is an example of aurora in Jupiter. It's a little swirl of blue, and it's very beautiful. It's like, I don't know, something that popped out of a Disney animation. So, yeah. Excuse me. So now I'm going to wrap it up there. Let's talk about why I said possibly other gas giants have extremely hot atmospheres. This is because we just don't have enough evidence of what is happening right now. Since our technology is not as strong, we've hypothesized that since Jupiter and Saturn have these events that are occurring that causes the high temperatures to increase, then other gas giants like Uranus and Neptune should also have the same effect, the same function, right? So yeah, it might. So I'm saying is, since we've seen that in Jupiter and Saturn, these events have happened, then it might occur somewhere else, like Uranus and Neptune. So yes, and scientists right now, in the future, are trying to find ways to create better technology to take pictures of the auroras and finally figure out why things are happening the way they are, the extremely hot atmospheres in these gas giants. And the scientists are saying that the reason why they can't send the technology out there to capture these images is because, for example, Uranus and Neptune, those are the gas giants that there weren't any auroras captured on the planet. It's because their magnetospheres are super hot. So yeah, that's why we just don't know much yet until we have further evidence. So I'm hoping in the future we can finally create something that can help us see these beautiful auroras and help us end the research and finally come up with an answer. So yes, thank you for watching my video, and I really appreciate it. You guys have a great rest of the day, and I hope you guys learned something new from this video. Thank you so much. I will probably see you, I guess, next time when Dr. Carlin assigns me a new video assignment. So yeah, thank you. Bye.